start. Okay, so let me show you what we're going to build today. So what I've got is welcome to an adventure. There are places you can go. Dungeon, kitchen, office. You're in the dungeon. So what I'm going to say is I'll type in office. So in the office, I think we might be missing some stuff. But okay, so oh, that's interesting. All right, this is not working exactly. Sorry. Always how it works, right? This is working at home, and now it's not. So we should be seeing it actually output stuff. Hold on a second here. Okay, so it's not printing stuff. Hold on a second. Did I change that? Ah, well, that's why that's happening. Okay. Right, so we see there's some stuff here. If I go to office, we see there's some things here, laptop. So what we're saying is there's various rooms, and they each have things in them, right? And for some reason, it's letting me pick stuff up, but it's not actually showing the inventory. Sorry, guys, this totally working. Oh, there we go. Okay, yeah. So, all right, so the key thing here, right? We might not have time to get to the navigation, but the key thing I want to get at is we're going to see passing by reference in action. We're going to have one vector, string vector, that holds the player inventory. And we're going to have string vectors representing stuff in a room, right? So, so we see, you're in the dungeon. There are some things here: gold, sword, dagger. We can say take gold. You pick up the gold. Right now we see we're still in the dungeon. We see there's sword and dagger, right? So now I'm going to move to the office, let's say. I'll say office. You move to the office. You're in the office. There are some things here. Laptop. You have gold. So I can say drop gold. So now we're in the office, and the office has laptop and gold in it. If I try to say take something that isn't there, like take foo, we see that there's no foo here. If I say drop bar, you don't have a bar, right? So anyway, so that's what we're going to do, right? And we're going to do it with no global variables. Right? So okay, let's get started. I am going to reuse a little bit of code from last week to take a string and break it up into parts. I'm not going to cover that again. I know a lot of people missed it, but two things about it. So first off, it is in the YouTube video, and I'll cover it again after class if you guys want. But we're running a little tight on time, and I want to make sure we get the inventory system. That's really what I want to show you guys. So okay, so I'll quit. Okay, so let's make a new project here. Empty project. Adventure. Oh, right. Adventure 2. What's that? And I'll make a source. Okay, so standard stuff is going to be include IO stream. Let's see, I need a bunch of stuff here. I need vector. What else am I using? I'm using and if we have time, we'll read some stuff from a file too. Well, I'll leave that out for now. Okay, so all right, so we're going to start off with our typical sort of loop here, right? I want to take some input and do some stuff with it. So, and I'll using namespace standard. Okay, so int main return 0. Nothing new here, right? So I'm going to give myself a bool is active, as we generally do. And I'm going to say while is active. Okay. So what do I want to do? Well, what I want to do is I want to do a couple things here. I want to let's get my notes. So you know, in situations like this, it's always helpful, or it's often helpful to kind of stub it out with comments, right? So I want to output where we are, output the objects that are there, output player inventory, take in input, check for quit, check for inventory actions. Okay, so first thing I'm going to do is I'm going to give myself a string to hold what our input is, right? So string input, and this is something that we did last week. So what I want to do is I'm just going to skip down to take in input for now, right? So we can get our cycle going. And one thing we have to be careful of is if I just use cin, I'm only going to get one word, right? So in the example, right, I was saying drop blah or take blah. So that's, if I just use cin, I'll just get one word. So what I'm going to use instead is getLine, which is in standard. So I'm going to say getLine cin input, right? So what that does, we saw this last week, but people that were at GDC, the first part of that, right, is where we're grabbing something from, and then the second part is what we store it to. The nice thing about getLine, though, is it will get the entire line. So what we're going to do is we're going to grab an entire line, and then we're going to break that into pieces to do more work with it. So like I said, we're running a little tight on time, so I don't have time to go into exactly how we're doing that. So I'm going to copy that from last week. And like I said, I'll explain it after class if you guys want to stick around, or it's in the YouTube video from last week. So Venture, there we go. All right. Oh, sorry. There we go. Okay. All right, so I'm going to copy this whole function from, it's exactly the same code as we talked about last week, so this will be in the video. So important thing is, though, is it takes a line and it spits out a vector of strings. So it's going to break it up by spaces, right? So that's going to give us the ability to do things like, know that the first word was drop or take, and the second word was some other thing, right? So very, very useful. It's a little more involved than I'd like it to be in C++, but yeah, just real quick overview is what it does is it successfully, it goes through and it looks for spaces, and then every time it finds a space, it reads up to the space and drops it out as a word. So yeah, I want to move on to the new stuff. So I'm going to use that, right? So and I'm also going to grab one other thing that we're going to use in a couple different ways, and I'm just going to dump this too. This is pretty simple. Oh, and for you guys to follow along, I know I would like you guys to follow along. So this is in an example code, right? So simple text adventure, and I think you actually can copy paste from here. So I recommend just grabbing get words from line and print vec. So grab it from there. I know I always tell you not to copy paste. This is one exception. So you can get through it in class, right? All right, so print vec is real simple. What we're doing here is the one interesting thing about it is passing by reference, but it's just runs through a string array and prints it out, right? The only slightly tricky thing here is that what I'm doing is I'm printing out a comma-separated list. And to make it nice, I'm making it so that there's no comma at the end, because that just looks sloppy, right? So I run through from I equals 0 to the size of the vector, right? I see out the thing. And then if I is less than size minus 1, right? Because size minus 1 is the last element. So if we're not at the last element, I add a comma. And that gives me a nice comma-separated list. Okay? Questions about that? Pretty simple. Okay. Okay, so let's make sure all that stuff is working. All right, so what I'm going to do is I'm going to get line, right? I'm going to say vector of type string parts equals get, what did I call it? Get words from line. Get words from line input. And then just to be clear, I'll print vec parts. Okay, so let me try that. We should get something that, okay, so I don't have any prompt yet, but if I say, take foo, we see take comma foo. If I say, drop bar, we see drop comma bar. And it's running together because I'm not outputting any new line characters or anything yet. But and I also don't have a quit, right? So okay. So first thing I want to do is check for quit. So I'm going to do that right in my loop. So what I'm going to do for that is I'm going to say if parts 0 equals quit, or parts 0 equals q is active. Okay, so is active equals false, right? So now I can quit. Not anything too earth-shattering to say. Okay? Were you guys able to grab that the code from the PDF? Okay, cool. Because I do want you guys to be able to follow along, so I just want to make sure that's working for you. Okay, cool. So now if we run that, no big deal yet, but we can quit out, which is nice. So now let's actually work on the ability to pick stuff up and drop it. So, when planning a project, it's always important to break it up into pieces, right? So that's why I made sure that we were getting some text, right? I made sure that breaking it apart was working. Now I added the ability to quit. I'm going to leave the room navigation until later. If we have time, we'll do it. If we don't, we won't. But what I really want to, the next thing I want to add is inventory, right? And it's really important to work on just a part of your project at a time. Break off a little chunk, make sure that's working. Break off another little chunk, make sure that's working, right? So what I'm going to do is I have to think about how I want to deal with inventory, right? So there's a lot of ways I could represent objects. So in this case, I'm going to keep it simple. It's just going to be a vector of strings, right? So in a full game, I'd probably have some sort of class for an object, right? Like a game entity class is generally pretty common, right? So, but in this case, it's just going to be two vectors, right? So for starters, so I'm going to have a vector of string. I'm going to call a player inventory. And we'll get to multiple rooms later, but to have multiple rooms, we need to have one room, right? So I'm going to say room inventory. Okay? And just for the sake of being able to actually test stuff, what I want to do is I'm going to add some stuff to the room. So how do I add some content to that vector, the string vector? Room in, and I'm not going to press dot because if I do that, it'll bring up a bunch of stuff, and that'll be giving it away. But what do I have to do to add stuff, insert stuff into a vector? Well, there's multiple ways I could do it, but keep it simple. May I remember? Think of cafeteria plates. What do you do, like, if there's a springy stack of plates in a cafeteria? Push, right? So push back is what we're going to do. All right, so I'm going to say room inventory dot push underscore back. Somebody give me an object in our room. Broom. Okay. Okay. And let's add one more thing. So run in. So we have a couple of things. Somebody else give me an object. Come on. Stapler. Okay. Stapler. Okay, so now we've got our player inventory starts out blank, which is fine, right? And our room inventory is going to have a broom and a stapler. Okay. So now I want to do. So let's output where we are. But for now, we're just going to say you're in a room. Okay. So what we're going to do is we'll make this nice in that we'll output objects only if there's some stuff there, right? So how do I know if there's anything in the room, given what I've set up so far? Yeah, you basically got it. I want to use size, right? Not array.size, but vector size. Yeah. So, but yeah, it's the same thing. So I want to say if room inventory size is greater than 0, right? Then there's something there, right? So I'm going to say if room in size greater than 0. I'll say something like, yeah, there are things here. And then I'll say print vec room inv, and I'll see out a new line. Notice I purposefully left the new line to last, right? Because this is just, I think that's a little cleaner in this specific case, to have one line that says, there are some things here, and list the things. So, all right, so I wrote a lot of code. Let's make sure it's working. So we see you're in a room, there are things here. Broom, stapler. So far, so good. Okay. All right, so now I want to get to the meat of things, right? So what I'm going to do is I'm going to write a function that deals with inventory, right? So it needs to do at least two things. It needs to be able to deal with dropping and taking, right? So, in a full-on text adventure, if you guys haven't played them, go play them. Zork is a great one. Hitchhiker's Guide is a great one. There's a lot of others. Anyway, so we have a much more robust thing, right? We're just going to deal with a couple of verbs here, drop and take. And I need to pass in a player inventory and a room inventory, right? Because I need to do some checking there. I don't want to let the player take something that isn't in the room. I don't want to let them drop something that they don't already have. That doesn't make sense, right? So, and I'm going to do all of that through the magic of passing by reference, right? Because what I really want is I want this player inventory to just exist in one place, right? I don't want to be passing that around because even though this isn't a lot of data, it's just a few strings, right? It's really not that big in the grand scheme of what computers can do. But if it exists in more than one place, it's highly likely that it'll get out of sync, right? So one place where the player inventory exists might have gold and a stapler, and the other place might only have the stapler, right? And that either gives them stuff they shouldn't have or gets them mad because they're missing gold. So let's do neither of those things. So what I want to do is I'm just going to, all right, so let's see. We checked for quit. Okay, and now I want to check for inventory actions. So the way I'm going to do that is with the following. I can go up here. right before main, let's say. And I'm going to say void process inventory action. It's a long name, but I might abbreviate that a little bit, but it doesn't hurt to be clear. So what am I going to pass in? Well, I want to pass in the input, the actual input, right? So the array, vector of strings that represents something like drop blah or take blah, right? And I want to pass in the two inventory stacks, basically, that I'm operating on. So what we really do in a real game is we would use something probably a little bit nicer than just a straight string vector to hold that, because we've got this concept of a list of objects that are in a place, right? That place could be in my inventory, personal inventory, or in sort of the inventory of the room. So those are close enough concepts to each other that I'd almost certainly want to have one class that implements functionality for both, right? So I have some sort of inventory class. Now it might just be a wrapper around a vector, a string vector, but it probably would do at least a few other things, right? So anyway, but for now it's just going to be a straight vector of strings. So I'm going to say vector. Oh, and I said let's do this. Let's do that. Oh, sorry. Let's do that. So notice I'm going to pass all of these things by reference, right? So I'm not going to copy stuff, right? Because even it just is kind of, not that it really matters that much in this case, but it's just inefficient, right? We've got this list of strings. There's no reason to actually copy that to pass it into this function. For the parts, right? There's very strong reason not to copy the inventory vectors, right? Because I'm going to make changes to them. If I drop something, it's going to leave the player inventory and be added to the room inventory. If I take something, I want to do the reverse. I want to take it out of the room inventory and put it in the player inventory. So if I don't pass by reference, this is pointless, essentially, right? Because it'll do the work, but it won't have any effect. So it's like you can't pick anything up. It's like made of water or something. No good. All right, so okay, so that's a bunch of stuff, right? That's hard to see. I'll make this a little smaller since you guys are... Actually, what I can do is, I'll do this, actually. That's better. Which is totally fine, by the way. That's absolutely fine to do, right? We haven't talked about this in a long time, but remember that C++ does not care about white space. It only matters in the sense that having a space between two things makes them two separate things. But once they're broken up into two separate things, having any number of spaces or new line characters doesn't matter, right? So if you do have sort of a lot of stuff going into a function, this is a typical thing to do. It's totally fine in C++. It's actually really rare to have a language that doesn't work like that, with the only notable exception being what? Anybody know? I think somebody said it. Python, yeah. Python actually uses white spaces. Meaningful, it's a horrible idea. All right. Okay, so now what do I want to do? So, all right, so first thing I want to do is I want to give myself the item. I want to find out what the item is. And that's a little tricky because now, so I'm going to test parts index 0. Actually, before we even get there, I want to make sure we have at least two things, right? Because this only makes sense if the player has said take something or drop something, right? If that isn't the case, this function should do nothing. So, real easy test for that is I'm just going to say if parts.size less than 2, return. Right, so just real easy test. Now, if I've got that, there's a lot of ways I could do this, but what I'm going to do is I'm going to go ahead and find out what the item is. Now, what's that mean? So an easy way to do it would be this, but it wouldn't quite work. So let's say a string item equals parts 1. Okay, because imagine what we're saying is take something, right, or drop something. Now, what's the problem with doing it that way? Can you think of an input that wouldn't work with that? What if there's a rubber ducky? What happens? If we take rubber ducky, not quite. What would parts 1 be? What would the second word in take rubber ducky be? Rubber, right? Take rubber ducky, right? So we get take rubber. We wouldn't have a rubber ducky. We'd have just a piece of rubber. That doesn't make much sense, right? So what I want to do is I want to make sure that we get everything, right? So and a lot of times it might be 1, but we're going to be a little bit better than that. We're going to make sure that we deal perfectly well with multiple word inventory things, right? So here's what I'm going to do. I'm going to start off, I am going to still have a string for item. I'm going to start it off as an empty string, and here's what I'm going to do. I'm going to say, various ways I could do this, but I'm going to say for int I equals not 0, but 1. I less than parts dot size I plus plus. Okay, that's almost there, but there's one little problem. Anybody see it? Again, think of what would happen if we said take rubber ducky. What would item end up? What would the value of item be if we said take rubber ducky? It's kind of a subtle thing. And it's really close to being what we want. What? I'm sorry? Oh, sorry. Yeah. So, well, let's just try it, right? So we've written a bunch of code, so it's a good time to try something. So, all right. So I think we've got this to a place where we can test it, right? So I'm going to say, I'll just go down here, right, and I'll see out item. Okay. So, and let's make sure we're actually calling this. So I'm going to go down here, and I'm going to say process inventory action, and I'm going to pass in parts. I'm going to pass in player inventory. Oops. Player inventory. And what do I call it? Room inventory? Room in. Now again, just to point out, this looks like I'm passing it in directly, right? I'm not using the address of operator here. But that's because I'm using references, and I'm specifically saying in my function that those should be references to what gets passed in. So it's actually going to modify the thing. So let's just try it, though. So it should work. Right. So if I say take rubber ducky, we see rubber ducky, right? We don't see rubber ducky. We see rubber ducky. So really small thing, but kind of things we want to pay attention to, right? Oh, and I should be able to quit now, too, right? And I can, right? So so really simple. It's the same sort of thing. There's another reason I kind of skipped over. I didn't really walk through this too much, because we're doing the same thing here. So what I want to do is, if we're not at the actual last thing, right, I'm going to add a space. So I'll say if I less than parts.size minus 1, item plus equals space. And I'll see out item, and I'll add a new line there. So that'll be a little better. So now if I run this, and I say take rubber ducky, we get rubber ducky. So awesome. And I can say, like, take a friend for rubber ducky. So now we get that whole thing, right? So we can have arbitrarily long things, and it's all fine. So I know that might seem like we're undoing work in a way, because we started with a full line, right? And I chopped it up into parts, and then I put the parts back together. But I want to make sure that for text adventure, I can pull out the first word as a verb. Take, drop, look at, maybe. Use with, stuff like that, right? So, okay, so now I'm ready to actually do some inventory manipulation here. So what I'm going to start with is if parts 0 equals take. So we'll start by picking stuff up, right? So we started with an empty player inventory and 2 things in the room, a broom and a stapler, right? So we'll start with picking things up. So if I'm saying I'm taking something, first off I want to know, is the item actually in the room, right? So I don't want to let people take stuff that that doesn't exist, right? So this gets back to sorry, I'm getting a little hoarse. This gets back to Anastasia's question earlier about, do we ever actually use begin and end directly? So first thing I'm going to do is I'm going to try to find something in a thing, right? So I'm going to look for the item in the room inventory that got passed in. So I'm going to type some stuff, and we'll talk about what that is in a second. There we go. Okay. Okay, so I just made an iterator, right? So key thing here, so we've got vector string, : iterator, right? So that should be, the way that's set up, that might look a little confusing, but this should be familiar enough to know that this is a variable name, and this is some sort of type altogether, right? Because structurally, it's kind of like, int mynum, right? Same sort of thing here. It's just that this is a little bit weirder, right? So what we've got here is vector string : which is the scope resolution operator. What it means is we want the iterator that's associated with, we want the type of iterator associated with vector string. So all it really means is an iterator is, basically a placeholder, right? It represents a position in a list-like object. So that works for vectors, works for arrays, etc. Standard library stuff, right? STL stuff. So I'm just going to make one, and then I'm going to do this thing, and we'll. So first thing I'm going to say is it. I'll call it iter, because it makes it confusing. So we'll say iter equals. So I'm going to say find. And I'm just going to write out some stuff here. Okay, so find. Another nice thing we get from algorithm. So what it's going to do is, so notice that if we ignore the third thing, right, this looks kind of like sort. We're passing in the beginning, and we're passing in the ending of a list-like object. We're also passing in something to look for, though. So what this is going to give us is it's going to set the iterator, because iterators are just kind of a placeholder. They're a position, right? So the iterator will have one of 2 values when we're done. It will either be the actual value of where we found it, or it'll be equal to end. So end here actually doesn't mean the last item. It means the actual end. It's like, the back cover, not the last page of the book. It's the back cover. Does that make sense? So yeah, so let me just type some more code, and it'll hopefully make it a little clearer. So we want to know, did we find it? Is that item that we tried to pick up, is it in the room? So I'm going to say if iter equals Okay, so if iter equals room_in.end, right? So that means kind of what's going on here, right? Is we've asked our system via the algorithm library to start at the beginning of our room inventory and check everything all the way to the end, looking for a specific thing, right? This will only be true if it got all the way to the end, meaning beyond the last item, and didn't find what we were looking for. So if this is true, that means we didn't find it. If it's false, it will have some other value, and that value will be equivalent to where we found it. So, and we're almost out of time, so I'm going to keep going here just to get this done. So, all right, so if we get here, right? Well, I'll say else, right? So now if we're here, that means we did actually find it. It is in the room, meaning we can pick it up. So picking it up, what does that need to do? There's at least exactly three things I need to do, I think. I need to remove it from the room inventory. I need to add it to the player inventory. And I probably want to tell the player that they picked it up, right? So all three things seem sensible, right? So first off, let's, I don't want to tell them that they picked it up until after they've done it, right? So what I'm going to say is room inv erase iter. Okay. So what's going on there? All right. So erase, what that does is it's part of the vector library, right? And it removes an element. And what we need to pass into it is where we want to remove, right? So there's at least two ways we can use it. We could remove more than one element. We passed in a start position and an end, both as iterators. But in this case, it's just going to remove one. And if iter was not equal to end, it's going to have the value of a specific place in the vector, where we found the first element that was equal to what we looked for. So I should make it clear that what we're doing right now would not remove all of the instances. So if we had a whole bunch of rubber duckies in the room, this would only remove one of them, which is fine. It's probably fine. Yeah?
So if we remove one, does the size itself of the vector change?
Yes. So great question, and yes. So erase, this is one of the things we get from having a vector. It makes vectors nice. So it'll knock it out, and the vector will shrink by one. So what it's not doing, like if we were using just a built-in array, right? We could definitely say, like, okay, so array element whatever is null. We could give it some null value, right? But then we'd have to, check for that, and it would make a lot of bookkeeping for us that is fine, but kind of annoying, right? So vectors make that a lot easier. Vectors are often a good way to go. All right, so this removes it from the room. Okay, now let's give it to the player. So I'm going to say player inv dot push back item, right? Because I'm adding the actual string there, right? I know that's a little confusing. We've got iter and item. Sorry about that. But yeah, so this is the location from which we're removing something. This is the actual name of the thing we're adding, right? And then I want to finish it off by saying, cout, you pick up a item, and a new line there. Okay. And one more thing I want to do is, so I'm back in my main here, right? I output, where we are. I say what's in the room, and then I want to output the player inventory too, which is going to be really simple. I'm just going to say if player inventory dot size greater than 0. Cout you have, and then I'll print vec player inventory, and then I'll cout new line. Okay, so I'm going to run that. Okay, so you're in a room. There are things here, broom, stapler. So first off, I'll say take rubber ducky, and we see there's no rubber ducky here. So that works. Cool. And now I'll say take broom. I say, we see you pick up a broom, and then we go back to the start of the loop. So you're in a room, there are things here, stapler, you have broom. And check this out. If I take the stapler too, so I'll say take stapler, I pick up a stapler. Now we see you're in a room, and we skip the line that outputs what's in the room because there's nothing there. And we see you have broom stapler. So we're right up at 6:30, but the inverse, so dropping stuff is the same sort of thing. It's really straightforward from there, right? Actually, let's just do it real quick, because I'm basically going to copy paste code, right? So what I'm going to do is I'll go back up to my my process inventory action, and I'm going to grab all of this code for taking. I'm just going to copy that. I'll paste it, and I'll say, instead of checking for take, I'll say drop. And here, instead of room inventory, I'm going to say player inv and player inv. And this will be player inv. And I want to change this message to make a little more sense, like you don't have a blah. And here I'm going to change this. I'm going to say player inv erase, and I'm going to say room inv push back, and I'll say you drop a whatever. Okay, so try running that. Okay, so we see you're in a room. There are things here, broom stapler. I'll say take broom. Pick up a broom. Cool. I'll say drop broom. Drop a broom. You're in a room, stapler, broom. Okay, so I mean we're out of time for today. So questions? I'll stick around and for a while, but questions about what we covered so far? Oh, so assignment. So take a look at the full source code, including the moving from room to room. Basically, the moving from room to room just means I've got separate vectors for each room, right? So I'm also reading from a file, which we talked about last week. Sorry I didn't have time to touch on that today, but to show you the file I'm reading from, just real quick. So we got example code. So this data file is really simple. It's what I'm doing is each line, either if it starts with room colon, I take that as a new room, and I break it up into parts using the same code, right? I take the second part to mean the name of the room. So I have one vector for names of rooms, and then I take the very next line if it doesn't start in room, right? I break that up and I take that as the contents of the last room. So I expect this to be formatted as a really simple data format, where lines alternate, either defining a room or saying what's in it. Defining a room, saying what's in it. So this setup, there's code up there to read it. Know that it wouldn't work if you had an empty room. That would break this, right, as it's written. So you have to have at least one object in each room if you want to use this. Because otherwise it would say like, oh, well, yeah, anyway. So, yeah, take a look at that, and what I'd like you guys to do is kind of take it, today's example, there's a little bit more to it on the online version. So take that as a jumping off point and make a really tiny text adventure with some inventory management and a couple other things, right? So, use some items maybe be able to look at items, combine items, maybe have a win state. If you get the amulet of Yendor, you pick it up, maybe you win. So, anyway. Okay, so questions about the assignment? Yeah. So take you're welcome to use the code. Like I said, I do ask that you type it in though. But the example I put up online does two things, right? It does the inventory management that we just talked through, right? It also lets you it reads from a file, which you guys can do or not do. That's up to you. It also allows you to move from room to room. So I'm looking for at least that. Move from room to room and have inventory. I'm sorry we didn't cover all of it today. Please, if you do get stuck, just email me as soon as possible. But all that stuff is up there as an example. So take that and then add some stuff to it. That's it.
So if we do decide to do the file, file management or whatever,
Yeah.
getting from the file, I should say, how do we turn the file in? Do you?
Oh, just give that to me too.
Okay.
Yeah.
So it should when you compile, it should just find the file.
Well, you'll have to. So good question, right? So you'll have to make sure that the file is next to the executable. But as far as giving it to me, just make sure you give me the C++ file and the text file. That's fine. I generally I compile all you guys' code anyway, so that's fine. But yeah, for running it, that's what you saw me right after the break when I was trying to get this running. I had to make sure that the text file was next to the executable, right? In a couple places. So both in where your source file is, but also where the executable goes when it's made, which is in the debug folder. So, okay. Anastasia.
You covered getting that in last week's.
Yeah, we used files too. So I know I don't want to require anybody to stick around, but I'm happy to stick around a little bit for you guys that were at GDC last week. If you want to hear about, I'll just do it anyway. You can stay or go. If you go, it is available on the YouTube video audio recording from last week, or 2 weeks ago, rather.
The example link doesn't work though for simple chatbot.
Oh, does it still do that? I'm sorry. That's why I fixed that. Okay. All right. Sorry. I thought I fixed that, and I'm sorry. I think it's okay. There you go. I'll fix the link, but if you make the link, so the link it goes to is WK7. If you change it to week 7, it works. I will fix that, but just know that it is up there right now. Okay, so that's it for this week. You got to go. Go ahead and go, and have a great weekend. But like I said, I'm happy to stick around. It's not a requirement. Last thing I would ever do is ask you guys to stay late on a Friday. Everybody staying? Wow. Okay. All right. So cool. All right. So let's add to this. I'll keep it as short as possible, right? But what I'm going to add to this example, right, is a couple things. I'll add the file reading, so we can talk through that real quick. And I'll try to get. We'll see. Yeah. Yeah. Yes. So so this will all be on when I upload the next set of YouTube videos. Right. So So let's talk about the files first. Okay. So so you guys can grab that file. It's nothing really it's really simple. Feel free to make it yourself if you want, or copy paste this. But yeah, so the key thing is that we've got. So I invented my own data format for this. That's a pretty standard thing to do, right? And the decisions don't really matter that much. It just matters that they're consistent, right? So in this case, I decided I'm going to have one line to define a room and another line to define what's inside the room. And I'm going to make those strictly flip back and forth between each other, right? So there is a lot of ways that this would break, right? It's not the most robust thing, but that's fine because I'm the only one making it, right? So this is not really meant for people in general. It's meant for me or my teammates, which is fine. So okay, so let's talk about that. So first off, I have to think about how am I going to store this data, right? So what I'm going to do is I'm going to have one vector, string vector, that's just going to be a list of room names. Then the next thing I'm going to do is I'm going to have a vector of vectors. It's totally fine. It's just like you can have an array of arrays, right? So and the reason I'm using vectors for everything is because I want to be able to, the whole point of having this data file approach is if I want to add a fourth room, that should be really easy, right? I shouldn't have to recompile my code for that. So I don't want to lock that in. Because, if we scale this up, what would really happen is I would throw in some dummy data to this, and then this file would go off to the game designer to play with, right? Or, I mean, that might be you, but that's you in a different role, right? So, there's one role where you're just writing code. There's another role where you're tweaking the game plan, right? So, okay. So let's talk about that. So, see you next week. Okay, so I already included fstream. That's what we need to do for file input output. I'm also going to do one other thing, and this is something we actually didn't talk about last week, or last time. And then I'm going to include cassert. Now, what's that? So what assert does for us is it lets us assert things, right? So we'll come back to that in a minute, but it gives us a way to easily shut down our code if we're missing a resource. That's one good way to use assert. It basically will stop your code from running if a given thing is not true. So, I'm sorry, if it's true. Well, we'll get to that in a minute, right? So, okay. So what I want to do is, again, like I said, I promise no global variables, right? So we're not going to have any global variables. But what I am going to do is I'm going to go back to my main, and I'm going to give myself 2 new chunks of data for the room data, right? So I'm going to give myself, there's a lot of ways I could do this, but I'm going to give myself a string vector. I'm going to call it room names. And now this is going to look a little weird, maybe, or maybe not. But I'm going to say vector. Okay, so this looks a little weird, maybe, but a vector can store data of any type, right? And a string vector is a type. So there's absolutely nothing wrong with having a vector of string vectors. So we say vector, string, and so it looks a little weird, and do note that I've got less than. So this is kind of like parentheses, right? And inside there I've got vector string. So we've got 2 brackets there, or 2 greater than symbols. But key thing is that it's all fine. We just have a vector that's instead of a vector holding a string, or strings, we have a vector holding vectors that hold strings. Totally fine. Okay, so what I want to do next is I'm going to give myself a function to initialize stuff, right? So I'm going to, and it's going to be void. Yeah, there we go. Okay. Okay, so I'm going to init rooms, and I'm going to pass in 2 vectors, right? So I'm going to let the init room function handle everything about setting stuff up, but I'm going to pass it in by reference again, right? I'm going to pass in by reference the 2 things I want to fill up. In this case, it's going to be the names of the rooms and the contents of the rooms. So I'm going to say vector string ampersand, because we're passing by reference, names, and then vector. Okay. So yeah, so nothing really all that new here, other than it's a vector of a vector. But in both cases, I'm passing in a reference, so that we can fill it up inside here, and we know that that'll be accessible in our main function, right? So that's cool. All right, so now I want to open a file. This is pretty cool, right? So I'm going to say if stream. And I have to give it, so let me just write this. Oh, sorry. Okay, so an if stream is an input file stream, right? So this is going to give me a handle to a file. It's going to let me pull data out of a file. Now, I didn't write 1 line there, I wrote 2. So this line in and of itself is going to open this up and set this, it's kind of like, see you next week. So room file is going to be the name of our variable. It's a slightly different way of initializing stuff. So basically what we're doing here is we're saying, give me an if stream named room file. But as we do that, we're giving it the location. So this rooms.text is going to be expected to be wherever our code is. So we'll have to make sure that that's the case. Meaning, yeah.
Well, you could continue. It's just like, it's kind of.
Oh, just to finish that off. So it's going to be, it needs to be where the code is, right? So I'm going to make sure it's in a couple places. I'm going to make sure it's where our source.cpp is. And I'm also going to make sure it's in our debug folder, right? So when it actually gets run, it's right next to that executable. So, yeah, go ahead.
Is there a way that you could actually make a file?
Oh, yeah, definitely.
Like,
Yeah.
Yeah, say instead of just like having to make it like outside, just like make it in the code, like
Absolutely.
at the beginning, and then just pull from it.
Oh, well, yes. So I'm not sure if I would do that. So if I was going to do it from the beginning, I'd probably just make it in code and just have it in code, right? So files are just for storage, really. Like, now you could totally, though, like let's say we were going to make something that was a procedurally generated text adventure, right? We could totally have it be that when you say new world, like kind of like in Minecraft, you say new world, right? It could generate room data, and then there'd be some save operation that would save it out to a text file. That would totally make sense, right? And yeah, I don't want to talk about that today, but I'll work that into. I'll try to work that in an upcoming class, like saving out a text file, because it's totally useful, right? But what I want to get at though is this is important, right? So when we do this, when we say if stream room file, and then a file, right? We've opened that file, meaning we've kind of got a reference to that. It's open for reading or writing or whatever, right? And so I want to make sure that before I forget anything, I call roomfile.close, which is good practice. There's another way that you can end up with sort of sloppiness, causing problems for you, right? Is if you leave a file open, you never close it. Right? So you get in these situations where, like, let's say you want to delete rooms.txt, but if you don't do this, then your OS complains at you because it's still open, right? So just good practice to any time in any language. Some languages are nicer about this than others, but I would say anytime you open a file, make sure you immediately close it, and then go back and do work in between. It's safer that way. Okay, so now I want to use this assert thing I was talking about. So okay, so check it out. So I just said assert room file. So asserts are really good, and this is a good example of when assert can be helpful. So I'm going to try running it and watch what happens. Now, note that I haven't added my rooms.txt to anywhere in this project yet. Right? So I'm just going to try running it and watch what happens. Oh, maybe I have added it. Oh, I'm not calling init rooms. That's my bad. Okay, so once I've set up my vector, my content, I'm going to call init rooms. Okay. Oh, whoops. And I need to actually give it room names, room contents. Okay, so I'll pass that in. I'll run it. Failure. Right? But this is good failure. This is what we want. So what we see is, well, this isn't too helpful, right? But we see that it closed down our program, right? So I'll abort, and we should see something. Wow, that's kind of annoying. All right, well, all right. So what's going on here is, I'm sorry the error message isn't more helpful, but so what assert does is you pass in something that can be evaluated for true or false, right? So if it's a truth E value, meaning it's non-zero, non-null, nothing will happen. If it's not, though, the whole program will shut down. So this is a good sort of way to prevent things that are problems from becoming bigger problems, right? So I shouldn't do anything with this if we didn't successfully get room file, right? So I'm kind of forcing my program to immediately shut down everything if we don't find that file. There's other ways it could deal with it, right? But in this specific case, it's kind of like if I don't have the room data, I don't have a game in this case, right? So it's probably better to just force it to shut down. And it's one like really sort of iron fist kind of thing you can do to make sure you can do things like assert if a variable is greater than 0, right? To make sure that if it ever goes negative, it just shuts down your program instead of bubbling up and causing weird problems, right? So yeah, we could also do that, right? But yeah, so you're totally right. We could. What would be a little harder is to actually shut down the program, right? So this is definitely a hardcore response, right? Because this should never happen, right? So assert is when you want to consider using assert is when you've got something that should never, ever, ever, ever happen. There's never a good reason for it, right? And like missing an important resource is a good example, right? Like, if it's something that you just want to optionally do or not, right? Here's an example of when I wouldn't use assert, right? So we've got a function that deals with just dropping and taking inventory, right? But there's no guarantee that the parts we pass in contained drop or take, right? So in that case, if we didn't say drop or take, we might have said, look or use or who knows what else, right? I just want to just not do anything. That's not like an error, really. It's just a state that I just don't want to respond to, which is fine. But in this case, there's never a good reason that this should be not found. It's a big problem for me and for my program if this is not found, right? So, and it might be the case that if I didn't do this, if I just let it go, we'd have weird errors, right? We'd have weirder errors in that we just would be lacking key data. Anyway, use it or don't. It's just something to kind of put in the back of your head. It can be useful. Right? It's something that gets used a lot in big projects when you're dealing with a lot of people and a lot of code. It's good to just throw in assert to make sure that certain cases can never, ever, 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 ever happen. So consider it. Okay, so now I want to make sure that my rooms.txt. So I'll. Okay, so I've got my rooms.txt. I grabbed it from the site, right? And I'm going to go to, all right, so this is adventure 2. So I'm going to copy this file. I should, let's see. I'm going to paste it there, which might let it run. I think I actually have to put it in debug too. Okay, now that seemed to work. Okay. All right, so notice I put it the same place as source.cpp, right? Because when file names are, by default, they're going to be relative to wherever the thing is running, right? So this is okay for development, but it would mean that if we wanted to give this to anybody else, we would need to make sure that our exe gets packaged with the text file. And there are various ways to do that, right? A really simple way is you just zip it up, right? There are better ways to do that once you get more and more assets, right? You make an installer, right? Okay, so cool. So just to make sure that that's working, I want to run through that file and I'll just print all the lines. So let's make sure that that's working, right? So I'm going to give myself a line, and I'm going to say while get line. Okay, so we see getLine again. So for those of you guys that weren't here last time, so we introduced getLine, right? And getLine can be used in a couple different ways. So we're using it in 2 distinct ways here. We're using it once to get direct input from the player. That's fine. We're using it here to get input from a file. But in both cases, what we're doing, what's the similarity is the first thing is the source. The second thing is where we put it. Right, so source of CN is fine, but this is also a stream. It's of type stream. That's fine too. So that's cool. So we'll grab that, and this should work. I'll try running it. Cool. and we see what we wanted to see, right? We see room, kitchen, stuff, room, office, stuff, right? So cool. All right, so now what I want to do is I want to process that. I want to make sure we actually initialize our rooms. So let's do that. Okay, so first thing I'm going to do is I'm going to break up whatever came in, right? So I'm going to say vector string parts equals get or parts. That's what happens. You forget what you call stuff. So, all right, what did I call it? Get words from line. Okay. So get words from line. Line. Okay. So now, based on the specific way I've set up my data, I know that if I have a new room, the first element is going to be room colon. It can be whatever you want as long as you stick to it, right? So, yeah. So I'm going to say if parts index 0 equals room colon. Okay, so here I found a new room. Found a new room. Else, found objects in a room. Okay? So again, this isn't terribly sophisticated. I'm looking for one thing, and every line is either declaring a room or filling it up with stuff. That's it. We could definitely expand this. We could say, this goes on, and we could make it as complex as we want, right? And eventually, it becomes something like a Skyrim data file, right? But this kind of stuff's nice to keep it simple. Yeah. Right. Oh, yeah. So, yeah, I'm glad you asked, right? So, just to be really clear about this, right? So, while get line room file line, right? So, an individual call to get line is going to read from a stream of some kind, right? So, there's at least a few different types of streams, right? So, we've been including all semester, we've been including IO stream, right? And then I included F stream, right? So, stream is just an input or an output. Think of it as like a channel for data to flow through, right? So getLine is going to read from a stream and store it somewhere. And if we're at the end, getLine will spit out something that basically evaluates the false. So upshot of that is we can, thanks for asking because I skipped over that. So yeah, so we can put it in a while loop. And what we'll do is this will read the next bit, put it in this variable, and then we can do whatever we need to it. And then we read the next thing. And eventually, since every file is finite, right, it'll eventually be false, and that's fine. So this is one of the only times I ever use while loops, is to read through files. Because in most cases, for loops can do whatever it was you thought you needed a while loop for. With two exceptions, I would say, like stuff like this where you don't know how big it is, and or like is active kind of thing, right? To have a game loop. So anyway. Okay, so we found a new, so we have two types of lines, right? So if we found a new room, I'm going to insert that into our room names. All right, so I've got names, right? So I'll say names push back parts 1. And for the objects, it actually is really simple. All I'm going to say is contents push back parts, all of it. Right? So push back, what we pass into that depends on what, see you next week. So what we put into this argument depends on what type of vector we've got. So in this case, names is just a straight up string vector, right? So we pass in one string. But contents is a vector of string vectors. So we just pass in a string vector. That is our whole list of parts. Yeah.
I can imagine vector of vector. You mean vector is a growing array, right?
Mm-hmm.
So one vector, if one vector is growing, and inside of the vector, also another array is growing?
Yeah, so it's easy to visualize as long as we're not talking about more than 3 dimensions, right? But it's pretty simple. And then just think of it like, so our names is like this. So our names is like this. So we've got, we had a kitchen, we had an office, and got to have at least some sort of game-like thing. We had a dungeon, right? So our contents, though, is kind of like this.